Welcome to my YouTube channel Mechanical Magic Mechanical Learning Tutorials. So in this video I am talking about one of the problems that will be based onto an Otto cycle for the different kind of calculations of the temperatures or different points. So let us see which kind of data is given. So generally this problem it will be for 7 marks into Gujarat Technological University, or you can say GTU, December 2012. So let us see the data. An Otto cycle having a compression ratio that will be 8 has pressure and temperature at the beginning of the compression are 1 bar and 27 degree centigrade. So that will be the initial conditions is given. If heat transfer per cycle is 1900 kJ per kg, so find the pressure and temperature at the end of each process and take the value of CV, or you can say specific heat at constant volume, and that will be 0.718 kJ per kg Kelvin. So let us see the data. At beginning, an Otto cycle having a compression ratio. So compression ratio it will be representing as R of C representing as a compression ratio, and that will be equal to 8. And temperature at the beginning of the compressor, or you can say pressure and temperature at the beginning of the compression are 1 bar and 27. So P1 that will be equal to 1 bar. So that will be converting into pascals. So 10 raised to 5 Pascal, and temperature T1 27 degree centigrade, so that should be converting into Kelvin. So T1 equal to 300 Kelvin. Then the further data says that if heat transfer per cycle is 1900 kJ per kg, so that will be representing as a heat supply to the system or cycle. So QS 1900 kJ per kg. And the last data it will be given specific heat at constant volume 0.718 kJ per kg Kelvin. So CV. So find out the pressure and temperature at the end of each process. So P2, P3, P4 and T2, T3 and T4. It will be necessary to find out. So generally these questions it will be occurs for the 7 marks theory. So let us see onto the PV diagram of the data. So x-axis that will be representing as a volume, y-axis that will be representing as a pressure. So as from the Otto cycle, or you can say constant volume heat addition and heat rejection cycle, so 1 to 2 process representing as a adiabatic compression process, and 3 to 4 and that will be representing as a adiabatic expansion process. So both are indicating like PV raised to gamma equal to constant, and from the data 2 to 3 process and 4 to 1 process that will be representing as a constant volume heat addition and constant volume heat rejection process. So according to that cycle, V1 equal to V4 and V2 equal to V3. So as from the data, here it will be representing as a P1, P2, P3 and P4. So starting with the first process, and that will be process number 1 to 2, or you can say adiabatic compression. So P2 upon P1 that will be equal to V1 upon V2 raised to gamma. So simplify and put the value P2 equal to P1 into V1 upon V2, that will be representing as a compression ratio as from the data. So finally you will get the P2 equal to 18.38 bar. So that will be the first answer. Now T2 upon T1 that will be equal to V1 upon V2 raised to gamma minus 1. So just put the value of T1 and V1 upon V2, that will be equal to compression ratio. So just you will find out T2 equal to 689.22 Kelvin. So that will be the end of adiabatic compression process P2 and T2. So that will be the pressure and temperature after the adiabatic compression process. Now, as from the Cp and Cv relation, so Cp upon Cv equal to gamma, so Cp equal to 0.718 into 1.4, so that should be equal to Cp equal to 1.005 kilojoule per kg Kelvin. Now I am interested for the constant volume process, or you can say constant volume heat addition process 2 to 3 over here. So P2 V2 upon T2, that should be equal to P3 V3 upon T3. But 2 to 3 process, that will be representing as a constant volume process. So V2 equal to V3. So finally you will get P3 equal to P2 into T3 divided by T2. So just put the value of P2 from here, T3 and 10 raised to 5, and that will be converting into pascals, and divided by T2 from here. So that will be in the form of T3 over here. So for the process 2 to 3, Qs, that will be heat supply, equal to mCv, specific heat at constant volume. So T3 minus T2. So Qs means heat supply, that will be given m for the 1 kg of mass, Cv that will be given, and T3 minus T2 from here. So you will get the answer of temperature at the end of heat addition process, and just put the value of that T3 into this equations, so you will also get the P3 over here. So that will be the end of the pressure and temperature of constant volume heat addition. Now the process 1 to 4 or 4 to 1 heat rejections QR, that will be equal to mCv T4 minus T1. So once again, similarly 1900 for 1 kg and constant volume heat rejection process, so T4 minus T1. So you will get the answer of T4. So that will be 2946.24 Kelvin. Now V1, P1 and T1 equal to P4, V4 and T4, and you will see that V1 equal to V4. So P4, that will be equal to P1 T4 upon T1. That will be P4 equal to 9.82 bar. So this is the simplest method to calculating the pressure and temperature at the end of each process. So P2, that will be equal to 18.38 bar, P3, that will be 88.95 bar, P4, that will be once again 9.82 bar, and T2 689.22 Kelvin, T3 3335.46 Kelvin, and T4 2946.24 Kelvin. So 6 answers, 1, 2, 3, 4, 5 and 6. So if you understand and if you like it, then subscribe and share Mechanical Magic, Mechanical Learning Tutorials. Thank you.